Hi, I'm Chris Albino, the CEO of SharpMed. I'm a physician and an engineer, and today I'd like to talk about a problem in medicine that crosses both areas, engineering and medicine. And that's the 14 centimeter problem, why nasal cannulas don't deliver what you think. Think about it, a nasal cannula in the nose, half the oxygen more than likely goes out in front of the face because it's an open system, and the other half has to go from the tip of the nose all the way back to the vocal cords on the average 14 centimeters. Again, nasal cannula has limitations, but this is the main go-to that we have. The oxygen has to travel from the tip of the nose all the way back to the vocal cords. Now let's talk about what you breathe. When we breathe oxygen or air, we're breathing about 21% room air oxygen. Oxygen coming out of the tip of the nasal cannula comes out at 100%, and ideally we'd want this higher concentration when it reaches the vocal cords. The question is, does that take place? We've assumed that's the way it works because that's how many of us were trained. The studies on this topic are limited and the results have been mixed, but again, this is our main go-to product, a nasal cannula. I'm going to show an engineering demo. This is not a human head. Human head is very, very complex. So this may not be 100% accurate. We're not trying to say that. This is designed to show dilution of a gas, specifically oxygen, as it travels. In this video, you're going to see a oxygen measuring device, a ruler, and a nasal cannula. Let's run the video. Okay. So the tip of the nose to the vocal cords is approximately 14 centimeters, as you can see on this ruler. So the oxygen is flowing through the nasal cannula at 100%, which is close on our monitor at 96%. Watch what happens when we march out just a little bit from the nasal cannula, and imagine what's going to happen with your patient with a nasal cannula in their nose. So the monitor is at 0, which is the tip of the nasal cannula. And as we get to 2 centimeters away from the tip of the nasal cannula, it's already dropped into the high 20s, low 30s. When we get 6 centimeters from the tip of the nasal cannula, it's already dropped to 23%. That's, to me, impressive how oxygen gets diluted down so fast as a gas. Let's do another demonstration. Again, an engineering demonstration, a little bit higher fidelity. We're now going to use a plastic tube to represent or simulate the nasal passage. Let's run the video. So what we're attempting to show today is roughly what a nasal cannula does when you try to take oxygen from the tip of the nose all the way back to the vocal cords, which are approximately 14 centimeters. This is the tip of the nose. Here's roughly where the vocal cords are. This is anatomically correct size. And again, this is 14 centimeters from the tip of the nose to approximately where the vocal cords are. By the time it goes through 14 centimeters, this also accounts for the fact that some oxygen goes out the front of the nose, some goes down the throat to the vocal cords, but a lot of that's mixed with ambient air. So you're going to get something much lower than you would like. Instead of 100% in the back of the vocal cords, you're getting about mid-30s%. Again, this is not meant to be a showcase for a human head. This is basically designed as an engineering demonstration to show what happens when oxygen can be diluted at distance. Our company designed something called a turbo O2 cap. This device, which is green, it sits on top of an ET tube and it delivers 100% oxygen down the ET tube, taking a static ET tube and converting it into a high flow oxygen tube. The main idea is to deliver oxygen much closer to the area of the vocal cords. On the bottom left, you can see the turbo O2 cap sitting on top of an ET tube attached to oxygen tubing. What is coming out is theater smoke because you can't see oxygen. So in order to show what oxygen could look like if it flowed down an ET tube, we simulated this using theater smoke. You've actually converted an ET tube into a high flow oxygen tube. To the top right is an anatomic mannequin. We're going to show the same theater smoke going down the ET tube, and as the volume picks up, you're going to see it bathe the entire back of the vocal cords. Imagine if this was oxygen, and again, imagine if you could see oxygen. Wouldn't that be great to be able to have this level of oxygen in the back of the throat? So in conclusion of a 14 centimeter problem, nasal cannula oxygen starts at about 14 centimeters from the vocal cords. The turbo O2 cap was designed to deliver oxygen much closer, as much as 0 centimeters from the vocal cords. I guess the question to yourself should be, which approach makes more sense for oxygen delivery during intubation? Thank you for your time. For more information, you can see our phone number and website listed.